On this section, or number 4, we are going to be solving inequalities, no longer equations, inequalities. And I hope you guys remember, when you solve an equation, the only difference between solving an equation and solving an inequality, like let's say we had a negative 2x is greater than 8. How do you solve that? Well, you simply divide by negative 2 and divide by negative 2, just like if it were an equation. But your final answer is going to be a negative 4, but it's not just a greater than symbol because you divided by a negative, because we divided by a negative right here, and right here on your last step, you have to actually flip the inequality symbol, so that becomes x is less than negative 4. Does that make sense? That was the only difference in Algebra 1 when we solved an equation compared to an inequality. If you ever divide by a negative, you have to flip the inequality symbol. And
it's only just dividing?
It's only when you divide or multiply by a negative. So anyway, if we look at number 4 here, we're going to end up isolating the radical first, just like if it were an equation. So you're going to have negative 1 right there and negative 1 over here. Your new equation will be 4 square root of x is less than or equal to 8. And then what do? Divide by 4 to isolate it. Divide by 4. You're going to end up with the square root of x is less than or equal to 2. And how do I get rid of the radical? Square it. And we square it. So my final answer is x. I don't need to flip it. X is less than or equal to 4. Everybody happy? Cool. But there's more. Right? There's more. If you think about that answer, it's not saying that x equals 4. It's saying that x is any number that's less than or equal to 4. So it could be a 4 in here, and that'll make it a true statement. It could be a 1 right here. That'll make it a true statement. It could even be 0 right here because 0 is less than 4. But if you think about the possible answers, this is insinuating an infinite amount of numbers. And we know that negative 1 will not work. Right? So you need to take a moment and see what would mess this up. Any negative numbers would mess this up. So it's this simple, guys. You go back to your answer, but leave space on the left side and think that the x has to be greater than 0. And then you just put that same inequality right there. And there's your compound inequality to this. Right? Because this is truly saying, the compound inequality is truly saying that your x has to be greater than 0, but less than 4. That's what it's saying. What do you guys think?
And it could still be equal to 0?
And it could be equal to 0. Because if you plug in 0 up here, the square root of 0 is 0, 4 times 0 is 0, and 1 is definitely less than 9. Right? But once you get to something less than 0, that's when it starts messing up. Because if you put a negative 1 in there, it's going to be an imaginary answer, and we know that we can't compare imaginaries with real numbers. So you have to make it a compound inequality sometimes. Let's go to the next one here. Check out number 5. Right here, this one's a little bit more challenging because we really do have 2 radicals and they're on the same side. So let's first move one of these radicals over to the left side by subtracting the square root of x. Let me rewrite my inequality. It's going to be the square root of x minus 5 is less than or equal to negative square root of x plus 5 on the outside. Everybody with me? How do I get rid of the radical? Square both sides, and I'm going to square this other side over here. And once again, we have the situation where we have a binomial squared. So I need to write that binomial twice. This is going to be a negative square root of x plus 5 times negative square root of x plus 5. And on the left side, it really does cancel out. So you do have an x minus 5 over here. Now on the right side, I need to distribute. So when I go negative square root of x times negative square root of x, well, a negative times negative is a positive, and the square root of x times the square root of x is just x. If I go negative square root of x times positive 5, that's going to be a negative 5 square root of x. If I go positive 5 times negative square root of x, that's also going to be a negative 5 square root of x. And if I go positive 5 times positive 5, that's positive 25. So I've distributed. Now I want to combine the middle terms, the like terms, the negative 5 square root of x and the negative 5 square root of x. We're going to have x minus 10 square root of x, and then plus 25. Let's bring down the inequality, which is still less than or equal to. We haven't divided by negatives on both sides. Let me bring down the x minus 5. And now, let me solve this thing. I have one radical. I need to get that radical by itself. So let me isolate the radical by subtracting 25, and also subtracting x and subtracting x. I'm doing 2 steps in one. So, of course, the x's cancel here and the x's cancel there. So let me rewrite this thing. I'm going to have negative 30 is less than or equal to negative 10 square root of x. What do I do next? Divide by negative 10. Now, when I say divide by negative 10, that's where you got to switch your symbol because you're dividing by a negative. So, what do I have left? On my right side, I have a nice, beautiful square root of x. You flip the symbol, change to a greater than or equal to instead of a less than or equal to, and a positive 3 on this side. So now, I need to get rid of that square root. So I am going to square both sides, and I will end up with x on this side all by itself, with that symbol right there, and 9. Now, of course, we're not used to seeing the answers with the number on the right and the letter, with the number on the left and the letter on the right. Let's switch it up. So let's put the letter on the left. So when you flip the whole thing, of course, that inequality is going to flip with it, because if it's opening up originally to the 9, it still has to open up to the 9. So there's my answer. Now the question is that answer good enough, or do I need to make it into a compound inequality? I need to make it into a compound inequality. And the reason for that is, if I go back to the original and I think about a 0 right, or a negative right here would mess it up. What would mess it up over? Actually, that's not even the original. Let's go back to the original. It's up here. I'm sorry. So what would mess it up? A negative number right here would mess it up, or even a negative number in here. So some of us are thinking that we need to put a 0 on this. Wait a minute. Let me rewrite my answer. Sorry about that. My answer is going to be x is less than or equal to 9. And a lot of us want to put a 0 right here, but that's not going to work. Guys, don't put a 0 right there, because a 0 would work right here, but a 0 would not work right here, because 0 take away 5 is negative 5, and that would give you an imaginary answer. So what number does it have to be over here on this side? A 5. So if you put a 5 on this side with that same inequality symbol, it gives you the compound inequality that describes that x has to be less than 9, less than or equal to 9, but it has to be greater than or equal to 5, because if it's less than 5, it produces a negative in there, which would mess it up. So are we starting to get the hang of creating these compound inequalities? All you got to do is go back and take a moment and check and see what would mess it up. And that's how you get that third, or that other number on this side. Now, that doesn't always happen. Check out number 6. If you haven't copied it down, go for it. So on number 6, it's as easy as adding 2, cancels, rewrite 3 square root of x greater than or equal to 12. Next step, divide by 3. Divide by 3. I don't have to flip any signs because I didn't divide by a negative, so I have the square root of x is greater than or equal to 4. Final step would be to do what? Square both sides, square there, square there. Final answer is x is greater than or equal to 16. Now the question is, do I need to put a number over here on this side to make it a compound inequality? Do I need to put a number over here? No, because this is saying that x is greater than 16. Any number that's greater than 16 is going to be positive. So I'm good with that. Does that make sense? Now, if it said x is less than 16, then yeah, you want to make sure you put a 0 on this side. Because if it's less than 16, you're eventually going to get to the negative numbers. But since it's greater than 16, it's okay, because you're never going to be able to get negatives in here if all your values are greater than 16. I hope this helps.